Hey guys, this is problem 4 for tutorial 2. Sorry this is so late. I meant to put this up on Wednesday and I just completely got preoccupied with something else that was going on, so I forgot to put this up. But here is problem 4, and I think problem 4 might look intimidating, but it's actually maybe the easiest one. Easiest truss problem you'll do in this homework set. The hard part about this one is deciding what to use for, because you don't, unlike the other cases where you had to analyze forces, not only you have to analyze forces in this case, but you also have to determine what load you want to use. So I will tell you that it asks you to list your assumptions, and I'm pretty sure that as long as you list your assumptions properly and your assumptions are reasonable, that you will get full credit, well, assuming you do the calculations properly. But yeah, because everyone's going to have slightly different assumptions, and they may or may not affect your answer. So I'll go into, if you came into office hours, I may have gone into a little too much detail for this. After looking over the solution, I realized that professor is just looking for some very, very broad answers. Okay, so let's look at this. More of the important things. The important things is that there should be, where does it say? It says there are 3 parallel trusses. That's one important thing. The deck is 25 feet wide. The loads are 2.8 kips, 4.4 kips, and 65 PSF load applied somewhere. The PSF load is your live load, and your point load is 30 kips. Okay, so you do not need to worry, and this is your dimensions that are given. You do not need to worry about load factors. I don't think you have to worry about load factors. We have to worry about things like how are you going to divide the load on the truss. So let's look at our truss very quickly. This is your truss. Your truss element is here. And I'm just going to draw that for you very quickly. Your truss is like, and it's divided into 5 equal sections. Five equal sections like this, and I did not do a very good job of drawing this truss, but you get the idea. You have it in front of you. This is pin, assume this is not connected. Okay, now you know that this is 25 feet wide going into the page. The professor has it drawn right here. Well, if you have right here, professor, there's a couple of ways you can divide this, because although your truss, you have 3 trusses that are for this 25-foot wide span, so you don't assume that each truss carries the full load. You need to divide it into some way. Those of you who came into office hours probably remember that I told you to do something like this, where this was 25. And then I said, well, pretend this is like a tributary area kind of thing. And then what is this? So I was saying that this truss would get 1/4, this truss would get 1/2, and this truss would get 1/4. Professor uses a slightly different way. He just says, well, just divide it by 3. You can use either. This one will probably be a little bit closer. This one is a little more extreme. But yeah, it's up to you. Just list this as one of your assumptions. This is an assumption you can use. For example, assume that the trusses are at the end, and center, whereas this one assumes that the 3 trusses are spanned equidistant. Yeah, I don't know what else you want to do for that. And then let's go with professor's example, just because it makes the numbers a lot easier to work with. this we'll just leave this as TW, and this I call it T. I would use this for tributary width. It's a term you guys will learn later if you aren't doing that already. Some of you who have already taken design courses would probably know more about this term. And then yeah, we have our timber load, our concrete, and our pedestrian live loads are all given in terms of kips per foot already, so we don't need to worry about that. Oh, the live load is given in terms of 65 PSF. We don't want PSF. We want pounds per foot. So what you're going to do is just multiply times TW. And TW is in units of feet. So this is going to become, and that'll give you the weight per foot of truss. So you have the weight here, right? And you're going to bring everything to the truss itself. So you're going to shrink it from 2D to 1D. Yeah, and then that's pretty much it. I mentioned to some of you that you can put the load P here, but try moving it around to see where you get your maximum P. Like try putting it here or here or here. Well, obviously these two will be identical to the other one, just reversed. But yeah, just try moving it around a little, see what you get. Feel free to use RISA for this problem, because RISA will make it. RISA is particularly good when you need to move stuff around, and yeah, that's pretty much it. Don't get thrown off by the dimensions it gives you. The dimensions might look a little bit odd, but all the information is there. You just need to be precise. Remember that 3.25 inches is not 0.325 feet. I don't know if you guys will make this mistake. That seems like the kind of mistake that I would make. I make very, very silly mistakes. Like I'll punch a number into the calculator wrong, but somehow when I go back to check my work, I'll punch the exact same number wrong in my calculator every single time I'm checking, which leads to like people like, why is this wrong? I checked it 5 times. But yes, this is to get just divided by 12, and and you should be set. But yeah, let me know if you have any questions. I'm gonna try and see if we can make this due on Wednesday morning as opposed to Tuesday evening, because I have office hours on Tuesday from 4 to 6, and I have a feeling that most of you are going to be working on this over the weekend. So yeah, we'll see. If you have any questions, definitely email me, or feel free to let me know. Also feel free to let me know if you have any trouble using RISA. I just started using RISA for this class also, so I'm not too familiar with it, but I've used other software before that's similar, so I should be able to help you if you have any problems with that. One thing. Do not, when you're modeling this, do not treat it like this. When you're modeling this, you need to bring all the loads. So you have your truss, right? And your truss has things like this. You cannot do this. You cannot do this. Don't do that. You cannot do this. What you need to do is you need to take like the load here and bring this whole area into a point load. So you get a truss that looks like this. Where this is yeah. So you're gonna have, you wanna if these are not your point loads, these are the distributed loads, and then these are your distributed loads, and then you're gonna have one point load. We'll call that P prime. You're gonna have let's call this L equals total distributed load. So this is going to be L over 5, L over 5, L over 5, L over 5, L over 10, and L over 10. And the reason why these two are L over 10 is because when you add up all these, you're going to get L. And L over 10 at the far ends because they only have half the area. So this should be twice as long as this. Okay, yeah, sorry for throwing that out there, but yeah, definitely let us know if you have any questions how you're modeling that. The reason why you need to do this is because you're using a truss, and truss can only be loaded at the joints like you learned in the lab. But yeah, let us know if you have any questions. I've said that several times now, but this is actually the end.